Okay, so here are two really fast and important things to talk about when we're talking about how to graph a quadratic. So if you're given any quadratic, given any like y equals ax squared plus bx plus c, okay, you need to be able to find two things. And those two things you need to be able to find are the vertex, okay, and you need to be able to find the axis of symmetry. Okay, and here is how you find both of these things. So given any ax squared plus bx plus c, remember that the value of a is not allowed to be a 0, because if it was, we just have a line. So we don't have that. So we got to find the axis of symmetry and the vertex. Well, it turns out that the axis of symmetry will always be located at the equation x equals negative b over 2a. So you can easily find the axis of symmetry just by taking the quotient of negative b over 2a. And this is the b that I'm talking about, and this is the a that I'm talking about inside the equation. Now, the vertex is a coordinate, right? So I put v, and then I put coordinate next to it. This stands for the x coordinate, and this stands for the y coordinate. Well, since the axis of symmetry goes through the x coordinate of the vertex, as you kind of like did on the little Desmos lesson, that means that we could find the x coordinate by taking negative b over 2a. So that's going to be the same thing. So how do you get the y coordinate from it then? Then you just evaluate and you take f of negative b over 2a. And what I mean by that is plugging it back into the function to find it. Okay? So let's do an example of this right now. All right, an example of this. So let's say I give you this quadratic function, y equals x squared minus 6x plus 4. So I have x squared minus 6x plus 4. Okay. Well, I can write down a few things that I know. I know the value of a is equal to 1. I know the value of b is equal to negative 6. And I know the value of c is equal to 4. That's pretty straightforward. A, B, and C. Is everyone okay identifying those three things? Yeah. Okay. Now, if I want the axis of symmetry, okay, if I take negative b divided by 2a, I would get the opposite of negative 6 divided by 2 times 1. Well, negative times negative is a positive, so that's 6 divided by 2, so this gives me a value of 3. So x is equal to 3 is the axis of symmetry, and it's a vertical line at x equals 3. Alright? Now that I have the axis of symmetry, I want to find the vertex. The vertex, again, is a coordinate. It's either the maximum or the minimum. I already know that the x value is 3. How do I get the y value out? Well, according to this, we can just plug the x value back through the function. So how do I do it? I do this. Y would have to be 3 squared minus 6 times 3 plus 4. So do you see what I did? I just took the x value and I plugged it back into my original function. Yes or no? Do you guys see that or no? Yes, sir. Yeah, so I took the 3 there and I replaced it for my x values here and here. That's what I did. So let's go ahead and compute that. What would that be if I were going to compute that? I'm in blue right now.
Wait, so what you did is you just plugged it back?
I plugged it back into the function, yep. So this would give me 9, right? 3 squared is 9. 6 times 3 is 18. And then I would add 4. So 9 minus 18 is negative 9. Negative 9 and 4 is how much? Negative 5. So here we go. So now I'm thinking that the vertex is at 3, negative 5. So let's go ahead and check to make sure that we did it right. You would probably use your calculator, but I'll just use this. We had the equation y equals x squared minus 6x, and then it was plus 4. Is that correct? And then we think that the vertex was located at the point 3, comma, negative 5. Okay? So I put all this information onto a graph. Check it out. Did I find the vertex at the right spot? I sure did. And then we also said that the equation for the axis of symmetry was the line x equals 3. And if we put that on the graph, does that indeed split the graph in two right down the middle? It sure does. We did that correctly then. Okay, so here's 2x squared plus 4x minus 1. This is a quadratic. I want you to tell me the location of the vertex and tell me the equation for the line of symmetry, okay? And you can use your graphing calculator to check to make sure you did it right. Okay, let's do this one together because we're kind of running out of time here, right? Everyone take a look at the board here and help me out and guide me through this. The first thing you're going to do is write down the values of A, B, and C. The value of A is what in this case? 2. How about B, everybody? 4. How about C? -1. Great. We're going to take a look at negative B over 2A. It's going to tell us two things. It's going to tell us the line for the axis of symmetry, and it's going to tell us the location of the x coordinate of the vertex. So I'm getting that this is going to be what? -4 over 2 times 2, which is -4 over 4, which is -1. So therefore, x equals -1 is our axis of symmetry. Very good. And then I want to take a look at the vertex. The vertex is a location on the coordinate plane. A location has an x and a y. I already know the x value because I did all the work to find it. How do I get the y value out of that? What do I do? I plug it back in. So I'm going to take 2, take -1, square it, add 4 times the -1, and then subtract 1. -1 squared is how much? 1 times 2, this is worth 2. This is 2 minus 4 minus 1. How much is all that worth? -3. Okay, so if we did this correctly, we think the x line of symmetry is x equals -1, and the vertex is at -1, 3. So let's go ahead and look, see if we did it. So if I graph this one, here is the graph of my quadratic. We said x equals -1 is our line of symmetry. Whoops, let's put it on this one. And it is. It definitely cuts the graph in half. Would you guys agree with that? And you guys told me that the location of the vertex is at the point -1, -3, and I would definitely agree. Okay, the last two boxes are going to be dedicated to how to solve a quadratic equation. So far, all we've been doing is looking at quadratic functions and expressions, and we haven't actually learned how to solve them yet. So I have this example for you. This is the equation y equals x squared minus 4. Okay, so this is that function y equals x squared minus 4. How do I solve this? What does that mean to solve a quadratic equation? Anybody know? Any thoughts? No? Alright, so let me get a different color here. What's that? You know the formula? You just don't know what it means? Okay. So here's what it means, alright? When we're solving a quadratic function, what we're doing is we're looking for the roots or zeros of a function. Roots and zeros mean the same things. Roots and zeros are the same thing as intercepts. So I know that the answer to this equation are these two values right here. And these are going to be x values. X could either be 2 or x could be -2. This is the solution to solving this quadratic equation. So what do I mean by that? That means that this is the point 2, 0, and this is the point -2, 0, right? So if I plug in x equals 2, I should get out a 0. And is that true? If I plug in a 2, do I get a 0 out of this thing? I sure do. So when I'm looking to solve a quadratic equation, I am looking to find the roots or the intercepts or the zeros. That's what that means. Okay, so I'm looking for these points right here. Roots, intercepts, and zeros all mean the same thing. Roots, intercepts, and zeros. So what they're going to do is they're going to give you they're going to give you problems, and they're going to say solve by graphing. So I'll do this part. You just have to watch and pay attention. We'll do it quickly with fluid math because it's a lot easier. So if I give you this graph, y equals x squared, and we'll say -1. I'll put this onto a graph. Okay. What are the answers to this? How do you know where the answers are? What are the two answers? -1 and 1. Why are those the answers? Because those are the roots, or those are the intercepts, or those are the zeros of my function. So they're going to give you a picture, and they're going to say what are the solutions to the equation, and how are they and use the graph to tell you. So what you're looking for is you're looking for the intercepts. Now, yeah. I get -1, right? Okay, what about this one? What if I just take the 1 away? Oops, sorry. This should be quadratic. There we go. Okay, now, what are the roots or the intercepts? 0, right? Okay. Okay. What if I add 1 to this thing now? Okay. Now what are the roots of the intercepts?
1.
No.
Nothing.
Nothing. Why is it nothing?
Because it's not touching anything on the
Because it's not touching anything on the
x-axis.
x-axis. So check this out, right? If this equation right here has no, it's possible to have no solution.
Oh wait, no, isn't it imaginary?
Yes, it's an imaginary solution. That's beyond the scope of Algebra 1. But for us, all they want you to be able to do is say there's going to be 2 answers, there's going to be no answers, or there's going to be 1 answer. Okay? So we just saw an example of each type of those. So how many would this have? If I gave you this, let's go back to math mode here. If I gave you this, if I gave you x squared minus 10, minus 10. Here we go. How many solutions does this have? Just from looking at the graph, how many? I heard one person say 2. Anybody agree or disagree? 2. Yeah, we agree, right? Where are they? They are right there, and they are right there. Those are my 2 intercepts, right? So I know that there are 2 of them. I'm looking for where the graph crosses the x-axis. So, okay, if I get rid of this, okay, if I take this away and I make this a 4, and I graph that, how many solutions does this have just from looking at the graph? It has 1, right? It has 1. Because it only touches the graph in one spot, right there. Right? You guys good with this part so far? Crickets. Yes? Okay, good. We're good. Okay. What if I did this? Get rid of this, get rid of this, all of this. What if I did negative x squared plus 2? And I graph that. Okay, based on the graph, based on the picture you see, how many solutions are there? There's 2. Very good. Okay. Now if I change that plus 2 to a minus 2, how many solutions does that have? 0 solutions. Very good. Okay. So visually seeing, you want to be able to identify how many roots, zeros, or intercepts there are just from a graph. Alright, the other way to solve a quadratic equation, instead of graphing it and looking at the graph and where the intercepts are, is to actually solve it using square roots. Alright? So, if I want to solve this using a square root, I have 3x squared minus 75 is equal to 0, and I'm asked to solve the solutions of this quadratic. Alright, so I'm going to go ahead and just follow my nose here in terms of what I would do with regular algebra. I would add 75 to both sides. Does that make sense? Okay, good first move. If I want to solve for x, remember the whole goal to solving the equation is to solve for x, what would my next move be? Divide everything by 3. Very good. Divide everything by 3. So that gives me x squared is now worth 75 divided by 3? That's 25. Good. So now, if x squared is worth 25, what solutions could I have here? Right, I can take the square root of both sides, so x could either be 5 or x could be negative 5. Those are the two solutions that I could have. 5 or negative 5, all right? What if I gave you something like this? What if I gave you m squared minus 36 is equal to 0? And I ask you to solve by just using square roots. Yep. M squared would have to be 36, then what? Square root of 36, so m could either be 6 or negative 6, right? I should actually be putting the plus or minus on the outside, the plus or minus on the outside, right? Because the principal square root of 36 is just 6. But if I put the plus or minus on the outside, I'm indicating that there's 2 answers for you. 6 and negative 6. Okay.